So today we have a very interesting question of fluid mechanics that was asked in GATE exam in 2022, and this question is the solid conceptual and very fascinating to hear that this question was generally asked by IIT Bombay and that particular year. So whatever the question is saying, I try to describe it to you. So here we have a jet over here, and this jet is striking a solid board plate which is at a rest, and this board plate is at perpendicular to the horizontal surface. And after it strikes, stream gets split into two, the upper one and lower one, and this board plate is having a hole over here which is of diameter 1 centimeter, and the respective velocities of the streams are given here, and we have to find the force required to hold this board plate stationary. So we generally look to solve this question by a very famous known principle, that is whenever we are asked to find the force that we require to hold it anything, we generally follows Newton's second law, which is the most fundamental law governing all these kind of situations. So first of all, if we consider Newton's second law, which is what? Applying Newton's second law. So generally whenever we are asked to find force, we generally look to this law. And here what is Newton's second law? We all know that rate of change of momentum of any body between two time interval t1 and t2, that is equal to the force we apply. So it is what? So F we can define as m times dv by dt. This is the most fundamental law which we are going to use in this question. So if we apply conservation of momentum concept here, the very fundamental Newton's second law, so we are applying here the conservation of momentum. So the moment just before it strikes here, let me draw it for you. So the moment just before it strikes here, it will be the initial momentum of our solution, and moment just at the moment it strikes, it will be the final momentum. So if we consider that kind of system, so we can use over here as delta p, that is change in momentum. So delta p will be equal to force required, that is this force is we are looking at. So delta p we generally look in is in x direction over here, as the momentum is a vector quantity. So we balance it over x direction, and I define my coordinate system as this is x direction and this is our y direction. So this delta p can be written as p final minus p initial, it is equal to f. Final momentum, the moment at which it strikes, we are defining it as final momentum, and as it strikes, the the mass, the rate is diverted into the upward direction. So therefore the final momentum of this whatever we have defined system is 0. So the final momentum is 0, and the initial momentum can be written as, so I write it F is equal to minus p into initial momentum, and this initial momentum can be defined as m into v, and this m can be written as density into volume, so rho a v, and this v one more time, so it will be rho a v square. So this expression is of our momentum, the initial momentum, and this is with minus sign over here. This the minus sign here indicates the force is the force is required, as we can see here, the force is required in the opposite direction of the momentum change. So we have to apply force over this direction as to keep this board stationary. So right over here we have density as 1000. So for a moment, for a time being, I am neglecting this minus, as I've told the significance of it in the calculation. So we have density as 1000, area is pi by 4 into d f square minus di square, and later I will explain what df and di significance. And we have v as 20 square. So df and di, if look at the diagram over here, we have df as this whole diameter, and di significance the whole diameter of hole. So by looking at this expression, eventually we will be realizing that this mass flow rate is nothing but the deflected mass which is getting deflected by getting thrust over this plate. So if we solve this, we have 1000 into pi by 4, and this df is 2 centimeter, which is 2 into 10 to the power minus 2 this square, minus di we have 1 centimeter, so it is 1 into 10 to the power minus 2 square, and this is 400. If we solve this, we will get 30 pi. And lastly we have f is equal to minus 30 pi Newton. And I have already told you this negative sign contribute to the directional factor. So the final answer of our problem is 30 pi. And the one more case of this question can be asked in future upcoming years, that what if we keep this board here, the board is inclined 90 degree to the horizontal direction, but what can be asked, that it can be modified as we have kept this board as. So the question, the same question can be modified into different versions of it, and each of that gets difficult. Like it can be asked, what if the board plate which is at rest is inclined to the horizontal surface at angle theta, and then there is a stream getting striked and it deflects over this plate. So this question is also a good of good taste, but the main part over here is to realize what the concept is. And the more difficult version of this question can be is like, since in this one also the plate is at rest, and what if we have this plate moving, like consider this plate is moving with velocity u. So what would be the force to keep it is stationary, and what will the force acting on the plate board? So these are the different versions of this question that is important to get known. So in the upcoming video I will be covering these topics also, and till then keep learning. I thank you for your kind attention. Thank you.